So when you're adding and subtracting terms with I, when you have complex numbers that you're adding and subtracting, it's really just like adding and subtracting like terms. So if we have A, we want to distribute that negative sign. 5 minus 3I minus negative 2 is plus 2, minus positive 4I is minus 4I. And then just like combining like terms, negative 3I, negative 4I is going to give you negative 7I. 5 plus 2 is 7. And that's all there is to it. That's your answer. What did you say? No, it doesn't have to go first. It really is just your preference. I will take it either way. So problem 3b, we are just adding there so we don't have to do any changing of the signs. 4 minus 4 is just going to give you 0. Negative 3i plus 3i is going to give us 0 as well. So this one, our answer is just 0, and that's all we can do. And for the got it question, we just have more examples of the same. So for A, we are not changing signs because we're adding these two quantities. 7 minus 3 is 4. Negative 2i plus I is just negative I. For B, make sure you distribute your negative. Minus 3 plus 2i. 1 minus 3 is negative 2. 5i plus 2i is 7i. So there's your simplified form. You guys try C and D on your own, and then we'll compare answers. Alright, so you should get 12i for C and 18i for D. Both of your constant terms, the real numbers in both of those canceled out, leaving you with a pure imaginary number, 12i and 18i. So that's all there is to adding and subtracting. You do it just like if you were adding and subtracting like terms. What we're going to do now is we're going to multiply. So just use your distributive property, 3i times negative 5. Just like I would be a variable, we multiply the 3 and the negative 5 to get negative 15. And I just stays being multiplied by negative 15. 3i times 2i is going to be 6i squared. Now, get ready to be a little bit angry, either at me or at math or whoever you want to be angry with. I'm going to tell you a rule. I squared equals negative 1.
Oh, no.
Because I is the square root of negative 1.
It is. I is the square root of negative 1. And if you square that, you end up with negative 1. You're mad at me because what if we write this out?
So it'd be negative 6.
I squared equals the square root of negative 1 times the square root of negative 1. Equals the square root of negative 1 times negative 1 is 1. So shouldn't that just equal 1? Yes. By the rules of real numbers, it should.
But it's not a real number.
It's not a real number. It's imaginary. It doesn't follow the rules. Okay?
Just like imaginary friends.
And we just keep it as negative 1. And yeah, your theory makes sense. My theory doesn't. But that's because it doesn't follow the rules of real numbers. The definition, I squared equals negative 1. Don't worry about proving it because you're not going to prove it in the same sense that you would use real numbers like we just did there with the square roots. Because I is an imaginary number. It doesn't follow the same rules. Exactly. Good. So anytime you have I squared, you can just fill in I squared as negative 1. So now we have negative 15I. Yes, minus 6.
Wow. This is interesting. I don't like it.
Okay. I'm sorry, what? That's right, you have to FOIL them. Very good. Because we're multiplying two binomials, that calls for FOIL. 4 times negative 1 is negative 4. 4 times negative 2i is negative 8i. 3i times negative 1, negative 3i. And 3i times negative 2i is negative 6i squared. Now, when you do this, what you need to do is you need to combine like terms. Negative 4 minus 11i minus 6i squared. Because your I values are like terms. Don't forget, we know what I squared is. I squared is negative 1, so we have negative 4 minus 11i minus 6 times negative 1. If you want to jump right to saying that makes that a positive 6, that's fine. You really don't need this extra step in here if you don't want to put it there. But now that we have I squared equals negative 1, we've created two more like terms. Negative 4 plus 6 is 2 minus 11i.
Wow. She did more work than we did. I'm just kidding.
No, that's what I just said while you guys were doing yours. You don't have to show all that work. I'm just showing you every single step that we did. Did you end up with the same answer?
Yeah.
And you're good. All right, C. Negative 6 times negative 6. We've got 36 plus 6i minus 6i minus I squared. So what happens when I combine like terms? Jack? Yeah, the I terms right here, they cancel each other out. We've got 36 minus I squared. But what is I squared? Negative 1. 36 minus negative 1 gives you an answer of 37. And let's do some more multiplying. Yeah, this is as hard as it gets. 7 times 3 is 21. I times I is I squared. What's your final answer? That's right. We've got 8 plus 10i minus 12i minus 15i squared. Someone tell me my simplified form here once I combine my like terms. Okay, good. So you just filled in that negative. So you did 8 minus 2i plus 15 because I squared is negative 1, giving you 23 minus 2i. You guys try C on your own. Okay, you guys should get 41. Who got 41? Yay, 41. Awesome. All right, now let's remember where we kind of came from with this. The whole reason that we started using our imaginary number I is because when we were doing our quadratic formula, if we got a discriminant of a negative number, we had no real solutions. They weren't real solutions because they're imaginary solutions that use the number I. So let's do this problem anywhere on your notes. You can just make a new sheet. And we will do x squared plus 3x plus 12. And we're going to solve this using the quadratic formula. So if we go through and we solve this, A is 1, B is 3, and C is 12.
Everybody's singing.
I love it. X equals negative B plus or minus square root B squared minus 4AC all over 2A. So when you simplify this the whole way, we get negative 3 plus or minus the square root of negative 39 over 2. So our discriminant here is negative 39. And when we said use the discriminant to not determine the number of solutions, you'd say, hey, it's a negative. That means no real solutions. But now we know more. We know how to write these two non-real solutions, because we can simplify the square root of negative 39 by using I. So we are going to write this as negative 3 plus or minus I root 39 over 2.